IR sensor circuit. A typical IR sensing circuit is shown on your screen. It consists of an IR LED, a photodiode, a potentiometer, an IC operational amplifier, and an LED. IR LED emits infrared light. The photodiode detects the infrared light. An IC op-amp is used as a voltage comparator. The potentiometer is used to calibrate the output of the sensor according to the requirement. When the light emitted by the IR LED is incident on the photodiode after hitting an object, the resistance of the photodiode falls down from a huge value. One of the input of the op-amp is at threshold value set by the potentiometer. The other input to the op-amp from the photodiode series resistor. When the incident radiation is more on the photodiode, the voltage drop across the series resistor will be high. In the IC, both the threshold voltage and the voltage across the series resistor are compared. If the voltage across the resistor series to photodiode is greater than that of the threshold voltage, the output of the IC op-amp is high. As the output of the IC is connected to an LED, it lightens up. The threshold voltage can be adjusted by adjusting the potentiometer depending on the environmental conditions. The positioning of the IR LED and the IR receiver is an important factor. When the IR LED is held directly in the front of the IR receiver, this setup is called direct incidence. In this case, almost the entire radiation from the IR LED will fall on the IR receiver. Hence, there is a line of sight communication between the infrared transmitter and the receiver. If an object falls in this line, it obstructs the radiation from reaching the receiver either by reflecting the radiation or absorbing the radiation. Distinguishing between black and white colors. It is universal that black color absorbs the entire radiation incident on it and white color reflects the entire radiation incident on it. Based on this principle, the second positioning of the sensor couple can be made. The IR LED and the photodiode are placed side by side. When the IR transmitter emits infrared radiation, since there is no direct line of contact between the transmitter and the receiver, the emitted radiation must reflect back to the photodiode after hitting any object. The surface of the object can be divided into two types: reflective surface and non-reflective surface. If the surface of the object is reflective in nature, that is, it is white or other light color, most of the radiation incident on it will get reflected back and reaches the photodiode. Depending on the intensity of the radiation reflected back, current flows in the photodiode. If the surface of the object is non-reflective in nature, that is, it is black or other dark color, it absorbs almost all the radiation incident on it. As there is no reflected radiation, there is no radiation incident on the photodiode and the resistance of the photodiode remains higher, allowing no current to flow. This situation is similar to there being no object at all. The pictorial representation of the above scenario can be seen on your screens. The positioning and enclosing of the IR transmitter and receiver is very important. Both the transmitter and the receiver must be placed at a certain angle so that the detection of an object happens properly. This angle is the directivity of the sensor, which is plus minus 45 degrees. In order to avoid reflections from the surrounding objects other than the object, both the IR transmitter and the IR receiver must be enclosed properly. Generally, the enclosure is made of plastic and is painted with black color.